Okay, so for this one, we know the initial speed of the car was 11.8 meters per second, and on the flat surface it took 40.2 meters to stop. So with that, we can figure out the acceleration from the brakes on the flat surface. We know that the force of friction is the friction coefficient times the normal force. The normal force is just mass times acceleration of gravity. So then in this case, we don't know the mass and we want the acceleration. So divide that by the mass and we'll get the acceleration. Then we can use this kinematics equation to solve for the friction coefficient. So instead of A is now split into the friction coefficient, mu, and gravity. So mu equals initial speed squared over 2gx. Plug that stuff in, and then mu equals 0.174. So then with this free body diagram, we know that the gravity that's parallel to the incline, parallel to the incline will be helping out the friction force in this case. So the sum of the forces is both of these in the same direction. So the normal force, you use the cosine of the angle, and then for the parallel one, you use the sine of the angle. So again, here's the full equation, but once we divide everything by m, we just get the acceleration in the x direction. So once everything's plugged in to this, we get the new acceleration is 2.201 meters per second squared. And then you just plug that back into this kinematics equation, rearranged to solve for the distance. And we got initial speed squared over 2a. Plug that in, and you get 31.6 meters.